Thank you for the introduction. Okay, so on the schedule it says I will talk about maturity in DRBD, and I will do that. And I'm hijacking a little bit my slot to talk about that we released the CloudStack HCI appliance today, and I will talk about that in the last 5 to 10 minutes of my time slot here. So let's jump into the low-level topic first. So the quorum implementation in DRBD. So why might this be of interest for you as CloudStackers? So there is a LINSTOR plugin in CloudStack to use LINSTOR and DRBD as a primary storage option. And this is how this connects to DRBD. And if you use the storage stack, then the volumes or the VM images in the primary storage are mapped to DRBD volumes. Now, what is DRBD? DRBD is a driver in the Linux kernel, and here on this slide, I have this orange box. I hope you can see that. That's like the Linux kernel, and here you see where DRBD is inserted in the I/O stack. In the case of a virtual machine, or how we integrate it in CloudStack, you don't have the file system and the buffer cache here. It's the KVM using it as a raw storage. Here on the illustration, it's a two-node system, but two-node systems is not what we do today. Today we do three-node systems. So in your probably huge CloudStack cluster, which has hundreds of hypervisor nodes, and maybe you have co-located the LINSTOR cluster with your CloudStack compute nodes. LINSTOR will choose 3 of your nodes for each of your storage volumes, right? Well, 3 or more, depending on your configuration. So I'm assuming you use a replica count of 2, so that means it will allocate LVM logic volumes. It will create 2 for your virtual volume on 2 different machines, and it will give you a 3rd machine in this DRBD cluster so that it has 3 nodes and the quorum algorithm is enabled. So I will talk about 3 machines. I call them ABC. This sign says it has a storage volume. I hope you can see it. And here this means the volume is accessible, but it's not backed by a logic volume in the LVM. And from the perspective of this DRBD resource, one of the 3 is in primary role, and this is where the KVM process opened the DRBD device. It can do I/O. On the other machines, if you try to open this DRBD device, the open will fail. Now it's one of the things is you can move the primary role around. In other words, you can move the VM around. You do a live migration through the CloudStack GUI, and KVM live migration, KVM opens it here, it closes it there, the primary role moved. So that's this P sign here. You can also move it to the diskless node. Of course, the IOs now go over the network and it accesses these nodes. For all the reads, it does a read balancing. For the writes, it writes to both concurrently. Also, to get you used to my terminology, we call the diskless node sometimes the tiebreaker node because it helps with this decision. Sometimes we call it the witness node. And when I'm talking about quorum, why do we need it? We need it to avoid the split brain situation. And so for the next part of the talk, I will always take you on the journey to investigate what happens if something fails. Now, let's get started easy. Let's break this network connection. that has no impact. Nobody cares. So all these nodes keep quorum. All good. Now, just for fun, let's consider the cluster is back into healthy state. Now we break the network connection between the two replicas. What happens now is that DRBD on this node realizes, oh, there is a primary node in the cluster because this message is relayed here. But DRBD does not do data replication through a third node. It is not doing that. So that means the disk state here turns to outdated. So DRBD on this node knows my copy is not up to date. And also the primary node knows, oh, there's a copy on C, and I know that the copy on C is outdated. So I changed the color here to highlight that. So we will come back to this outdated topic a little bit later. In case the connection heals, DRBD does this partial resync and brings the node back up to speed. So I think so far it was all easy to follow. Now let's get to the next level. Let's fail two connections. Or in other words, we have an isolation of node A. So it's isolated from the other nodes. Now it loses quorum because it's 1 out of 3. And 1 out of 3 is not the majority. So it loses quorum. I illustrated that with graying it out. The other two still have quorum, so this guy continues to offer the service. Also, I would still be allowed to do the live migration to move it back and forth. Let's isolate another node. Let's isolate this one. So these two are 2 out of 3, so they are still happy. This one is 1 out of 3, so no quorum. I can still live migrate back and forth here. If I try to live migrate over there, I think you would be allowed on CloudStack level, but the migration will fail. So it comes back as an error, and then it finds out, oh, it's still there. And now, let's try what happens if out of this situation, we reconnect this A node to C. And that's a two-step process. I need to disconnect it from B. And then I connect it to C. But here, the algorithm has like a special rule. It says, if a node has lost quorum, it cannot easily regain quorum by just adding a disk class. So this is one way to phrase the algorithm. The other way is that these nodes carry a so-called data generation identifier, which is actually a 64-bit random number. And this diskless node let me go back. This diskless node also has this random number, so it knows to which data generation it belongs. Let's put it that way. Now it gets disconnected, and when it now gets a connection established with an older one, it says, we don't really fit together. We cannot do this game. We are 2 out of 3. That just is not allowed in this situation. Okay. What's coming next? Yeah, and if we put this A back to B, right, they find out, okay, we have the same data generation. Both get quorum again, and they unfreeze the application. Oh, so maybe this is a detail I missed at this slide, even at this slide. So in the moment a node that runs the application loses quorum, DRBD no longer grants access to the data. For virtual machines, the best configuration is that DRBD simply freezes I/O. So that also freezes the virtual machine. So it stops. Everything stops in D state, right? Or let's say all processes that access it, but it is, I mean, the process from point of view of DRBD, the only process accessing it is KVM. So everything is in pause, right? So it's frozen. It regains quorum when A comes back, so it unfreezes, it continues, right? So for virtual machines, we want to have this freeze policy if it loses quorum. For other services, it makes more sense to configure it that it starts to fail IOs when it loses quorum, because we want then that the application is stopped. We can talk about that if enough time is left. Let's continue. Now, let's go to the real hard problems. Let's say the primary gets isolated. So we have concurrently these two network failures. So again, we have the primary losing quorum, freezing the KVM, everything stopped here. The other two nodes, they have quorum, and they see that this partition doesn't have a primary. So in order to restore availability of the application, it would be a good idea to start it. So DRBD exposes a lot of state someone could consume, and one of these state members is the promotion score. So these two nodes now offer a positive promotion score. And just as a detail, this guy offers a higher promotion score because it has a local copy of the data. This one also offers a positive one. Now let's assume there is some kind of high availability cluster manager, and that starts the application on this node. So is this a split brain? It looks like, because we have it running twice. No, it's not running, it's frozen. So it runs here. We have restored the availability of the application. So it's a failover, right? And what's the next step? Either the network restores. Yeah, let's restore the network. Let's do that as a next step. Then what happens is that DRBD figures out, okay, there was a new data generation formed by the application or the VM running here. Here it's in frozen state, and it goes from frozen state to I/O errors. So if this is something running in user space, let's say a file system and a MySQL database, what happens is that these kind of applications usually exit because the database gets write errors. What should it do? And that's all. That's really the preferred behavior. If we run this with our HA cluster manager, we even kill the application in this scenario, and it gets supported by DRBD delivering I/O errors. And after the application terminated, it closes the DRBD device, and recovery is complete. The application is cleared, a short resync happens, and everything is good again. For virtual machines, I think we are not there yet. So we will need some integration work on the CloudStack side, but I definitely want to get there. And let me put it that way, I think this is a lot better than doing Stoneth using, what's the name of the protocol? Yeah, you know what I mean. IPMI, Stoneth over IPMI and 15 minutes timeouts and all that. So the timing behavior we're talking about here is all in the range of 6 seconds by default. Okay, then I have 2 more slides regarding the quorum topic. One is graceful disconnects. So if I start from a healthy cluster and we do a graceful shutdown of this machine or a graceful disconnect of DRBD. So what happens in the disconnect process, this DRBD tells this guy, hey, I'm going away, also this one, and that guy tells it, hey, I'm primary, so if you're going offline now, it's pretty clear that your data copy will be outdated in just a moment. So it becomes outdated, and also the other guy knows that this one is outdated. And this is important knowledge, because an outdated node cannot become an active partition. So if we shut down the diskless node after that, this node keeps quorum, it keeps running. It's 1 out of 3, but it's completely valid that it continues to run. So it is an important difference between a graceful shutdown and an unexpected go to nirvana. Yeah, right. In the documentation, we call this the last man standing optimization. So you can have a 3-node cluster, 1 node can run if everything is done in a graceful way. Okay, so I cut it down that I am good in time. Then I will talk about what was not in the announcement. Today, so now completely switching gears, going from the lowest level of the stack to the highest level. I think it's a little bit hard for newbies to set up a CloudStack cluster. So I wanted to do something about it, and we created the Linbit CloudStack HCI appliance. So what is that? It's a bootable ISO, and you need 3 machines or more, and it will give you a running CloudStack with every component highly available. That is the CloudStack database, that is the CloudStack management daemon, that is the LINSTOR management daemon, that is the NFS gateway. I think that's it. And CloudStack primary and secondary storage configured in 20 minutes. And so that you get an impression of it. So it is based on Alma Linux. So when you boot this ISO, you will go through the Alma Linux Anaconda installer. And when that is finished on your 3 nodes or more nodes, and you boot up the machines, it will give you an URL. And then you type it into a web browser, and then you are greeted with a page like this. So if you count the dots, it's 10. So 10 steps to CloudStack. Number 1, you just need to press the button. Number 2, you need to identify your machines. So they have strange names. The IP addresses they get, maybe from the DHCP server, or you enter them in the Anaconda install. If you don't find a machine, click here to enter the IP address. If it's behind the router, this is the zeroconf protocol. Then you need to name the machines. You do it here. You give the cluster name and also the individual machines. I cannot show it you with the screenshots, but you type in here HCI and you have it in all 3 fields. So really easy to do. Then you need to wait about 30 seconds. You have these progress indicators. Then you end up at this screen. And here you select which of your nodes should be hypervisors running KVM virtual machines. So if you started with 10 machines and you mark only 5, you created a disaggregated cluster, right? So here I marked all 3. You have the gateway, the DNS that is from the DHCP probably, and then you just give it the system IP start, end of the range, instance IP start and end. That's it. Then you need to configure a little bit of the storage. So it will display you the storage devices it finds in your nodes. Then you can check them and create a pool. So the idea is you might have SSDs and HDDs in your nodes, and then you create an SSD pool and an HDD pool. So here I have only one pool. After that, you create resource groups. And the resource group, that's the LINSTOR speak. That is, here you have properties like I want that the volumes in this group are 2-way replicated or 3-way replicated. They should be allocated out of this pool or out of any pool, and a lot more details than we do here in the GUI. Then for the LINSTOR high availability, you need to give it a service IP address and the resource group where it should put the LINSTOR database. Then the CloudStack setup, so it needs the service IP address where the CloudStack web UI will be visible, and the service IP address for the highly available NFS server, and the resource group for both. And 15 gigabytes is the minimum for the NFS. And then you press the button and you will see the process indicators here for a few minutes. This takes a few minutes until it's done. And you're there. And if I do it, it takes me 20 minutes. And I invite you in the afternoon break, let's do it on my laptop. Take the time if it takes more than 20 minutes. And if you want to try it at home, get it from here.
Thank you, Philipp. And now it's time for questions. So, any questions in the room?
Does it help me when I already have a... One moment. Okay. Does that appliance help me with an existing CloudStack cluster?
Not really.
Not really.
Maybe it helps you. You try it out virtually and see how things are configured, and you can peek at the configuration and redo it on your existing one. But here, really, the focus is to get you going, right? So my impression is that a newbie coming maybe from a product I don't want to mention here, that for a newbie it will be a week or longer to figure out how to install CloudStack, read all the documentation, wrap your head around it. And I want to make this an easier experience. That's the reason. And what's really impressive, after you've installed it, you figure out, okay, where's the manager running? Okay, kill the box. The manager is back in 7 seconds. That's really impressive. I love it.
One question. How can we update the cluster?
Software updates.
Yeah.
Yes.
Drivers, firmware, it's in the same package or not?
Yeah. So please consider this like a technical preview right now. So right now it doesn't give you an update options. Starting in January, there will be update buttons. And here comes the money grab. I am So, you know, the Alma Linux updates come from the Alma repository. The updates of the Linbit components comes from the Linbit repository. And for the Linbit repository, you need to be a Linbit customer. This will come with a support bundle. So you have a single support partner for the whole appliance. But we are starting in January with that. So right now, consider it a tech preview. And to go more into detail, with the update button, so what happens in the background is that we test the combination of all these components in our lab. And we have a so-called version lock in the yum thing, right? And if you press the update button, it will use yum or DNF to get them all to the next approved combination of all the components, right? So it's a pre-tested update process you will run through. And the steps are, there's a button where you put the node into standby, then you can press the update button, and then you take it out of standby.
All right, thank you. Well, thank you, Philipp, and thank you.
Yeah.